In 1 through 3, we're asked for the 6 reciprocal identities. There are 3 pairs of reciprocal functions, and sine of theta is equal to 1 over the cosecant of theta, and similarly, cosecant of theta is equal to 1 over sine of theta. You're going to probably memorize those as one thing. Cosine theta is 1 over the secant of theta, and secant of theta is equal to 1 over the cosine of theta. And the last pair is tangent and cotangent. So tangent of theta is equal to 1 over the cotangent of theta, and cotangent of theta is equal to 1 over tangent of theta. 2 quotient identities that we need to know are that tangent of theta is equal to the sine of theta over the cosine of theta, and the cotangent of theta, being the reciprocal, is cosine of theta over the sine of theta. The 3 Pythagorean identities are sine squared of theta plus cosine squared of theta is equal to 1. And now if I take that first Pythagorean identity and I divide by sine squared, we get 1 plus cotangent squared of theta is equal to cosecant of squared of theta. Similarly, taking the first one, sine squared of theta plus cosine squared of theta is equal to 1, and dividing by cosine squared, we get tangent squared of theta plus 1 is equal to secant squared of theta. Those are the 3 Pythagorean identities. So, from those Pythagorean identities, we can write 2 variations. If we take the first one and we subtract sine squared from both sides, we get cosine squared of theta is equal to 1 minus the sine squared of theta. Similarly, if we take that same one and subtract cosine squared from both sides, then we get sine squared of theta is equal to 1 minus the cosine squared of theta. If we take the second Pythagorean identity and we subtract 1 from both sides, then we get cotangent squared of theta is equal to cosecant squared of theta minus 1. If we take it and subtract cotangent squared from both sides, we get 1 equals cosecant squared of theta minus cotangent squared of theta. Now taking the last trig identity, Pythagorean identity, tangent squared of theta plus 1 is equal to secant squared of theta, and subtracting tangent squared from both sides, we get 1 is equal to secant squared of theta minus tangent squared of theta. And if we subtract 1 from both sides, then we get tangent squared of theta is equal to secant squared of theta minus 1. In 5 through 8, we're using the given information and a Pythagorean identity, remember those are the ones that we just looked at with the squares in them, to find each ratio. Hint, do not sketch a reference triangle, it's unnecessary. Okay, so here's what we're going to do. We're involving cosine and sine, so I'm going to use the Pythagorean identity, sine squared of theta plus cosine squared of theta is equal to 1. The cosine squared of theta is 2/5. So we're going to replace, the cosine of theta is 2/5. So when we square cosine theta, we get 4/25, and that's equal to 1. And so if I subtract 4/25 from both sides, then the sine squared of theta is equal to 1 minus 4/25, which is 21/25. And that means that sine of theta is equal to either plus or minus the square root of 21 over 5. That being said, our theta value is between 0 and 270 and 360. That means it's a quadrant 4 angle, and in quadrant 4, sine is negative, so based on that, sine is negative square root of 21 divided by 5. In number 6, we have an angle between 180 and 270, and we have the value of secant of theta, and we're looking for the value of tangent of theta. So, if we remember our trig identity, tangent squared of theta plus 1 is equal to secant squared of theta. And now we replace the secant of theta with 4. Secant of theta with negative 4. Then secant squared of theta is 16. Subtracting 1, that gives us tangent squared of theta is equal to 15. And tangent of theta is either equal to plus or minus the square root of 15. Our angle is between 180 and 270. And that would be a quadrant 3 angle. And in quadrant 3, tangent is a positive value, so tangent of theta is equal to the positive square root of 15. That's how we decide if it's plus or minus. In number 7, our angles between 90 and 180, we're given cotangent, we're looking for cosecant. So I'm going to use the Pythagorean identity, 1 plus cotangent squared is equal to cosecant squared of theta. And we're given the value for cotangent. So cotangent squared is 16/9. And 9/9 plus 16/9 is 25/9. And if cosecant squared of theta is equal to 25/9, that means that cosecant of theta must be plus or minus the square root, which is 5/3. And now we have to decide if that should be positive or negative. And between 90 and 180 is a quadrant 2 angle. And in quadrant 2, tangent is negative. Let's see, that's not important though. What is positive in quadrant 2? Sine is positive. And if sine is positive, so is its reciprocal cosecant. So the cosecant of theta must be positive 5/3. In number 8, we have an angle between 0 and 90. And sine of theta is 2/3, and we're looking for secant of theta. Now, there is no trig identity that relates both sine and secant, but there is one that relates sine and cosine is the reciprocal of secant. So I'm going to use the sine squared of theta plus the cosine squared of theta is equal to 1. And we're given the value for sine of theta, and sine of theta is 2/3. That means sine squared of theta must be 4/9. So 4/9 plus cosine squared of theta must be equal to 1. I'm going to subtract 4/9 from both sides. 1 minus 4/9 is 5/9. And now we can take a square root. So cosine of theta is plus or minus the square root of 5/3. Now we have to decide if cosine should be positive or negative. We're in quadrant 1, so that means positive. And if cosine is positive, square root of 5/3, then secant must be the reciprocal of that. That would be 3 over the square root of 5, and we're going to rationalize that 3 times the square root of 5/5.